Hello everyone, my name is Kumar Aditya and in this video I will demonstrate the Amp-Sec balance principle using a DC to DC converter example. So here I have created this buck converter simulation in LTS Spice. My input voltage is 48 volt and switching frequency of this MOSFET is 40 kilohertz. So I have a switching time period of 25 microsecond. I have set the duty cycle to 0.5. So duty is 0.5 and therefore output I expect is to be on average 24 volt. Now as per Amp-Sec balance, also known as charge balance, if the voltage across the capacitor or this output voltage is periodic in nature, then average current through the capacitor, this average current should be 0. That is there should be no DC current or DC component of current flowing through this capacitor. Now let's see whether this is happening in this circuit or not. So I will run the simulation. In this simulation, on the top, this is the PWM pulses. The second plot is the V out or the voltage across the load or the capacitor. This red trace is the current flowing through the capacitor. Now this is my transient state, and after transient is over, circuit reaches the steady state, right? This is transient and this is steady state, and here you can see I have almost 24 volt output. Now let me zoom on to the transient state first. So this is my transient interval, and let me take a cursor aligned to one switching interval. So this is one switching interval of 25 microsecond. From here to here, this is 25 microsecond, right? PWM pulse, 50% duty cycle is on for 50% and it's off for 50%. Now in this interval, this is my 0 amp reference line. You can see the current through the capacitor is definitely has an average value which is not 0. You see, this current is never going below this 0 amp line, so it has a certain positive area, right? And you know that the DC value of a waveform or average is given by area under the curve by the time base. So it has certain DC component. Now if a DC current is allowed to flow through the capacitor, voltage across the capacitor will rise as per this statement, right? So we have seen in the last video on this Amp-Sec balance, voltage is I times dt. Now if I is constant or it is DC or it has certain non-zero average value, then we can take it out and it simply becomes dt. So if we keep on increasing this dt, this voltage will keep on increasing. Here we are increasing the time from 0 to 25 microsecond, and therefore voltage is also keep on increasing during this time interval. Now for the entire transient period, our current has certain DC component and therefore voltage keep on rising. But eventually this circuit reaches steady state, so voltage does not keep on rising forever. It reaches a certain peak value and then tries to return to the steady state value. But in the transient state, we saw this circuit definitely violates the Amp-Sec balance principle. And one takeaway from this is that when you are designing your converter, you make sure that the capacitor you have selected should have maximum voltage rating which can tolerate this peak voltage rise during the transient state. It is also important that your circuit should reach steady state as soon as possible, otherwise this voltage will keep on rising, right? Will keep on rising, and which is definitely not good. So transient state should be as small as possible. Now let's zoom on to the steady state. So this is the steady state. and I will take a cursor. So considering this to be my one switching interval, let me take another cursor. Yeah, so I have two cursor. I am not sure if this is visible, so I will draw on top of this cursor. So this is my cursor. And you can see in this switching time period 25 microsecond, my voltage across the capacitor is periodic. See, it's sinusoidal in shape and it is periodic in nature. It is repeating with the same frequency, and we saw from the Amp-Sec balance principle that if the voltage is periodic in nature, then the average current through the capacitor should be 0. And here, if you observe the current waveform, let me take the different color. You can see the area of this wave pattern in this time region is 0. This is my 0 amp reference line, and area of this curve is this area plus this area plus this area. Now this area will be cancelled by this area plus this area, right? Because this is above 0 amp line and these two are below 0 amp line. So it essentially verifies that in a steady state our capacitor is definitely following the Amp-Sec balance. So we learned from this example that when you are designing a DC to DC converter, the circuit will violate the Amp-Sec balance principle in the transient state, and therefore voltage across the capacitor will keep on rising. So it is very important that when you are selecting the capacitor, your capacitor should be rated to tolerate the voltage rise during the transient state, and it is also very important that your circuit should reach a steady state as quickly as possible, so that this voltage does not go to a very high value, because eventually you can select a capacitor to tolerate a high voltage also, but eventually this capacitor is going to be bulky. So shorter you keep the transient state, lower will be the peak voltage during the transient state. Now I hope you have clear understanding of Amp-Sec balance. If you have not seen my basic video explaining this Amp-Sec balance principle, I will leave the link in the description. So see you in the next video. Bye bye.